Hello ladies and gentlemen, welcome to the DPLA channel. Today we have another episode about our bionic prosthesis. Also in this episode, hello ladies and gentlemen. Welcome to the DPLA channel. Today we have another exciting episode about our bionic prosthesis. Also in this episode, you'll actually get to see its real actual tests in action. Well, here we go. Oh my God, hey Gleb, so shall we go and see what exactly got a bit wrecked? Ouch. Huh? Ah, you really should knock. Damn it, what exactly are you doing here anyway? Just messing around so I can wash with the pressure washer. What are you doing? Dmitry Pavlovich, they turned off the hot water at home. I want to shower. Just messing around so I can wash with the kercher. Come on, get dressed. Well, I finally came back from Priviskovo. The trip was interesting. My wife and I had a snowball fight. The temperature dropped to -35. We got a bit frozen, but had a lot of fun. Let me tell you about the test. It lasted 3 hours. When it comes to working in the cold, it's better than... It grips on really, really tightly. I had a fall on the snowmobile. I was trying to impress others, attempting to do a hop over, and I got dragged behind the snowmobile. I had to twist my arm like this. On the one hand, at least it moves, but it grips tightly. I fell off the snowmobile while trying to show off with a hop over and got dragged, so I had to twist my arm. It was scary, but also good. With this prosthesis, you can even stand on your heel or hang from it, but after 3 hours, something cracked and squeaked, and the prosthesis ended up like this, so it lasted for half a day of riding before it failed. So that's how I was riding. I was holding on with one hand like this. Well, here we are in our... I had a spare socket, but it broke after a day too. So that's how my ride went. I was holding on with one hand like this. Now here we are in Uvarovo. Here is Gleb, the lead developer. All of us...
We took everything apart, figured it out and acted. Gleb will explain what happened and what we'll do. After watching Priskovi's video where something snapped and whistled, we got a few ideas. For example, after receiving the video from Priskovi, I already had a guess just from the footage about what could have happened. We had a component like that. After receiving the video from Priskovi, I already guessed from the footage what might have happened. We have a component where there are two small bearings that hold the drive gear shaft. These small bearings are on the gear itself, mounted in the side plates. Well, one of these bearings couldn't withstand the abuse that was expected, and it turned into this set of spare parts with scattered balls. It completely disintegrated. Overall, the process of fixing the prosthesis took about 5 minutes. Yes, we replaced those bearings. Here, you can already see the bearings that we swapped out for bronze bushings. Well, if there's no bearing, then there's no problem. We really hope that these modifications will help improve both the viability and the durability of our product. It was also discovered that some of the fasteners had loosened and holes that were supposed to be round had become oval shaped. We solved this problem as well, of course, in the simplest way possible. Loctite thread locker and nothing comes loose. Well, actually everything else. It survived, even if not for a very long time, both for use in the cold conditions and under significant loads. But we continue testing. Dima continues to wear this prosthesis, and we sincerely hope that everything will keep going according to plan. So,
what else did I want to say? Let me think. Yeah, I've been wearing this prosthesis for about a week now. The prosthesis survives some cold and heavy use. Testing goes on, with Dima still wearing it. After a week, we're used to its weight, and the electronics work well. The so-called proportional control works well. It grips like crazy. The battery charge lasts for a day, which is basically enough. You plug in a Type-C, it's no worse than a power bank. We're still going to refine it. The batteries will be a bit different. What problem did we discover? Since the power comes directly from the batteries and is regulated by PWM, when the voltage drops, the grip strength and speed decrease. So, when the battery is about half discharged, you already start to feel uncomfortable. So, what did we decide to do? We decided to connect them together in parallel, just as we really needed to.
We want one S, yes, and we want 2S. In the end, we want to make a 2S battery pack and install a programmable DC-DC converter, which will allow us to adjust the voltage as needed. After the DC-DC converter, the voltage will be stable and consistent. That is, we can boost it to 12 volts, 16 volts, or even as high as 22 volts, depending on our requirements. We will choose the optimal value for our specific application. With this setup, we will be able to fully discharge the batteries all the way down to zero, meaning we can use up every bit of their stored energy without experiencing any voltage drop or loss of power halfway through the discharge process. This ensures that for the entire period during which the battery is able to deliver any amount of power, the speed and force of operation will remain consistent and unchanged from start to finish, providing reliable and steady performance until the battery is completely empty. Well, as I understand it, that's very important for the user.
The battery keeps full power until empty, which is important for users. What else? Yes, we're ordering a trial batch, about 50 units. We'll also be conducting endurance tests. I think we'll clamp audio.
Expander will write the software and it'll be compressing back and forth like crazy. We've already written about 70% of the internal testing program. It includes endurance tests and also, which I think is very important, we're developing firmware that will collect usage statistics from real people. Dima will wear the prosthesis for a week, logs will be recorded, and then, after analyzing this information, we'll extrapolate and figure out how long the prosthesis can operate on a single battery charge, how many times a day a person grips something. So Dima will wear the prosthesis for a week, logs will be recorded, and then after analyzing this information, we'll extrapolate and understand how long the prosthesis can operate.
We track grip frequency and force on one battery charge. This data is always useful, as shown by global practice. We need to figure out what 3 years actually means. Since I'm an active user, we'll take the time I spend opening and closing the hand, basically the total number of motorcycles. And well, we'll multiply that by something else, by a coefficient for a really extreme user, you know? And I think it really should hold up. Well, something will probably break off eventually, but honestly, I think that's not really necessary. Prosthesis makers claim a 3-year lifespan, but real durability depends on use. Simple designs should last longer. That is, I might not feel as strong. I'll say it again. It's amazing how huge the loads are here because of the long levers. So I could,
without feeling much discomfort in my hand, if the fingers were made of aluminum, just rip them right off.
That's it. Yes, we made aluminum fingers. I have aluminum fingers. For everyday life, aluminum fingers are enough. Very few people. Of course, we won't recommend riding snowmobiles. That's everyone's personal choice. But now I think, while we still have some snow left, we'll get together for a bit. The main thing is that it doesn't end up like always. Whenever we want to show something, it inevitably breaks. But honestly, I think it'll definitely hold up just fine. Also in the future, for this project to achieve real commercial success, the standard aluminum prosthetics should mostly have their parts made by die casting. Gleb hasn't seen tests yet. Let's hope nothing breaks. For success, aluminum prosthetic parts should be die cast, not milled. It's not possible to make these cheaply. Titanium and aluminum models both require costly die casting. If any subscribers can advise us on production, let us know. If someone can say if we can machine molds for casting,
our own Haas, that would be
not bad, so at least we'd know whether to be optimistic. I think we'd figure it out. We generally understand how it works, but we've never dealt with it before. Or, for example, if someone could suggest for a reasonable fee that we machine the molds for the fingers here on the Haas and then outsource them for a small batch to be cast. Just so we understand, because preparing for die casting is expensive and we'd like to make it cheaper. Even if we make the molds from tool steel ourselves, maybe not as polished. You see,
the overall surface finish quality of the prosthesis's mechanical parts, specifically under the glove.
The details inside aren't important. What matters is the surface finish of the mechanical parts and the prosthesis under the glove. We need it at the right level and we'll mill more if needed. This would help us, and we're ready to allocate a budget, but only to a specific person, not managers. I've never asked for donations, but help here would speed things up. Everyone here understands quickly. We just need 3 days of consultation. In short, we'll meet them, give them a hug, get them shoes, feed them, and give them some money. So please help us out. And one more thing I wanted to say. When we finish the endurance tests, the tests on myself, we'll have a trial batch. And I think we'll select, if there's interest, a couple of people for beta testing. I think that would be really great. It's one thing how I feel using it, but it's another thing for other people. In the future, we've figured it out. And I don't like it in terms of its durability. At Tabakovsky,
The quick release mechanism, to be completely honest, even on your grapher, of course, has some parts that have already fallen off or become loose over time. Even though Dima doesn't use the prosthesis super actively or frequently, I have noticed these issues.
on the quad bike, we'll make our own quick release.
I dislike it because it isn't durable. The quick release lost parts after a hit and only mostly survived. It was Konstantin already.
Yeah, I think it was Konstantin. People use it, yes, it's definitely convenient to work with. 90 is a number that comes after 89 and before 91. It is an even number made up of the digits 9 and 0. In mathematics, 90 is often used in counting and measurements, such as in the phrase 90 degrees for a right angle. In Roman numerals, 90 is written as XC.
Probably. Let's put it this way. The low gears, when resistance appears on the prosthesis, that's really something else entirely. So the low gear when resistance appears on the prosthesis is honestly a really cool development from Obok. So
Of course, we'll try to implement it ourselves too. Or maybe, you know what, I just got an idea. Maybe we'll make a multi-winding motor and a multi-coil motor with different torque characteristics. That would be really cool. And it wouldn't even require electronics, so it would be even smaller in size, like the motors they used to make on old machines, where they had several windings. One is wound for speed and the other for torque, both at the same current. That's possible too.
electronics are hard to control, especially at tiny sizes, but it's possible. What will we find?
Whether we'll find such a motor or have to make it ourselves, no, that's just overcomplicating things. The only problem is all this stuff is so tiny. I mean, you could leave the gearbox, for example, and
Do something with the windings, somehow figure it out. We'll think
in that direction. Yes, that's correct, because gripper, let me explain further.
clamp prosthesis. I know that everyone calls it a gripper. These, like the gripper clamp prosthesis, I also,
Don't know, I just know it's called gripper.
everyone calls it that.
Call it gripper, but honestly, everyone just calls it the claw. Yeah, it looks more like that. Funny thing, what do you think? We're actually not joking. When we make our own quick release, I think we should do this. Make a screwdriver prosthesis. We'll take a module like a Makita quick release and control it with one sensor for speed and another for switching. Imagine I put in a screw and just screw drywall in, living my best life. You could also attach a Dremel. An angle grinder is a bit too heavy. For example, reverse, what for? But imagine, since I have this kind of tool, I just put in screws, screw in drywall, living my best life. You could also attach a Dremel. An angle grinder is a bit too heavy. A Dremel, a reciprocating saw.
I'm not really sure, but I think a drill driver is most practical since it's used most,
It's a household tool, and I have several drill drivers.
at least.
You could also add a switch, even though you might not need it, but just to be able to turn it on and off. Well, you could add all sorts of things, even a torch, even though you might not really need it, but just so you can turn it on and off. For example,
When I was personally soldering heat pumps myself, I had to carefully clamp it like this. So I installed it.
for me,
Of course, when comparing you to the average user, well, when I was soldering copper pipes, it was actually really necessary, you know.
I highly recommend it. It's definitely great. So what else?
If they gave us,
A weapons manufacturing license lets you make cool things, but be careful. There are also many adult products. Entertainment ones too, like switching modes.
definitely with a quick release,
Yeah, of course, with a quick release. This and that, all sorts of things. Yeah, exactly. So that, you know, you can turn flaws into advantages. By the way, that's an idea too. Why not? In short, we need a quick release.
and
Then we'll hold a contest for the best attachments. Yeah, exactly. We'll also sell licenses, basically, so that, you know, supporters can make all sorts of additional and various features.
we'll definitely be making money.
And we're just talking about quick release mechanisms, like a license that allows you to put our quick release on your products. We'll be making money. By the way, gentlemen, we were just talking, as you've seen, I work out at the gym, and when I need to lift something, I have a sports prosthesis, everything's fine. But when I need to pull something toward myself, what I do now is use a special hook for deadlifts. I wrap it tightly to my stump with an elastic bandage. Right now, I've gradually worked my way up to pulling 40 kilograms, sometimes even 45. But I think if I go over 50 to 60, the device will tear up my skin. Maybe someone works with leather goods, maybe something for the forearm, something with lacing.
To make something flexible.
A prosthetic socket. Well, not flexible, you know, more like one with a hook, like those old knights or whatever they were called used to have.
Armor. So that there's maximum contact area to distribute the load. Yeah.
So if anyone, well, if anyone is working on this, please get in touch. We're still experimenting and might just scrape off a bit of skin.
We're going to get together, me, Gleb, and my wonderful wife, Maria, everyone's favorite camera operator, and go do something crazy.
On snowmobiles, maybe better. Was it recorded? It's late, we're behind, but what can you do? Testing is underway. The weather. We're testing the prosthesis in harsh conditions. Gleb is our engineer. Renat from Active Riders will operate the drone. On these BRP free rides, my naturally aspirated 850, which is a fantastic machine, and my beloved wife's, your favorite operators, turbocharged free ride, which is always a thrill to ride. And also the Lynx, which Nisha usually rides most of the time, but right now Gleb is on it, and that thing is pretty wild and unpredictable. And take a look at this guy. He completely forgot to change the belt on the utility sled. So if
We just stop and
something goes wrong, it's
kind of his. All right, okay, let's go now. On the smart.
could you please turn off the zoom? Go ahead. Drive over and carefully check it out from that side and let me know what you find. Everything has been checked and prepared, and there are no obstacles in your way. The path ahead is completely clear, and you have the go-ahead to move forward with confidence. All systems are ready, and you can trust in the preparation that has brought you to this point. Take a deep breath, believe in yourself, and know that you have the support you need. This is your moment to take action, to step forward, and to give it your best effort. Remember, you are fully prepared and nothing is holding you back. The opportunity is right in front of you, so embrace it and go for it. All clear. Now is the perfect time to make it happen. Hey, turn off the zoom. Passenger, go. Move him over. Starting from that side, work your way upward, making sure to carefully observe everything as you go. Gorm, are you ready to proceed? Gorm, please confirm that you understand the instructions. Now, move from the left side, just as we discussed. Make sure to check your surroundings and stay alert for any changes. If everything is clear, you have permission to go ahead. Proceed carefully and let me know if you encounter any issues along the way. All clear? Good. You may begin now.
Soft sounds of birds chirping softly. Confident. Yeah, you are fit. Confident. No matter I'm landing. You go off. Otherwise, here's a little strategic blunder, a small miscalculation in our plan, and what? Yeah, we got a bit stuck here. We pushed for about 20 minutes, really putting in some effort and using up quite a bit of energy. What? 25 minutes, you say? Well, that's even more time spent trying to get through. Let's go, my dear. Let's keep moving forward. Come on, my knight. Let's ride together. I'll film you as you drive into the pepper field, capturing the moment as you go. Why is it unclear? Let me help you out. What should I fasten you to? I'll fasten it now, making sure everything is secure before we continue. signal, Dima. I'm here for Pavel. No need to worry, everything is fine. We need to stay focused and keep moving forward. That's it, she's holding on now. No, let me just make sure everything is alright before we continue. Hey, it's okay, I'll take care of you, don't worry. Did you catch it, Pavel? Yes, I got it. Well, let's keep going straight ahead, just as we planned.
Да. Фу, понеслась. While we were going back and forth, the sun went down to the bottom, and off we go. Well, gentlemen, our trials have ended. While we went back and forth, the sun set, but it was better to do it right away. It's already +3 degrees, and maybe tomorrow there won't be any snow. The snow cover is decent, about half a meter, but on top it's just ice, like concrete. Still, we found a place to ride. We passed the test 100%. I don't know if it was caught on camera. You'll see my flight in the video. So how did it turn out? I got some air, but just a little bit. Into the wall, into the snowdrift, into the wall, into the ground. So how did it turn out? I got some air, but my hand slipped a bit since it wasn't in the right position. My legs stayed behind and I landed on my stomach, which wasn't great. So always wear protection. You can really get hurt this way. But the prosthesis took the hit. Nothing broke, so it's working. It settled in a bit. In the cold, the speed isn't that high, but as you saw in the videos, I can stand up straight and it holds everything. When traversing, get into snowmobile sports, folks. Even if you have some issues like I do, but it's all, of course, snow isn't the best for traversing. There are anthills and bumps, but I really enjoyed it a lot. So that's how we rode. Get into snowmobile sports, folks. Even if you have some issues like I...
Like me? Well, that's everything I did. Go for it. That's why it's so glad. What do you think? Did you like snow?
It was nice.
Like everything, just need to get used to it, but it was really great. Well,
what? Yes, that was actually Gleb's very first time riding, and he managed quite well for a beginner. Overall, his performance was not bad at all, especially considering it was his first attempt. I wish you all the best, Gleb. This was your well-earned stick of achievement. Watching this video really helped me dig out some useful insights. Really, not bad at all. You did a good job, and your efforts are definitely worth acknowledging. So, all the best to you. This was your stick of achievement, a reminder of your progress and hard work. Watching a good video like this one truly helped me dig out the snowmobile, as it provided clear instructions that made the process much easier overall.
this is just a pause, a moment to reflect before the journey continues. There is much more to come. The adventure is far from over. We invite you